Okay, let's go ahead and get started there, everybody. Welcome back to another, well, in this case, it's a 2 p.m. PST YouTube stream. I'm your host, Strange Bird Jim, and today we are going to be starting off with some Unreal studying. No Pega today. Wasn't able to get online fast enough to take care of that, so it'll just have to be the Unreal study session to start off with. Then after about an hour of the Unreal, then we'll have the video uploads an hour after that. And then, of course, Warframe starting at around 4 p.m. PST. So, or basically in about 2 hours or so. So, so that's basically the lineup for today. We're going to be joined by Blackheart in just a second. Matter of fact, here he is, actually, in the stage. So let me go ahead and invite him to speak.
Hello there, Jim. How you doing?
Not bad, my friend. And yourself?
I'm doing okay.
That's good to hear. Okay. Yeah, I was just letting everybody know that, I'm sorry for kind of being late for starting up the stream, but I mean, it kind of happens every Friday, to be honest. I can
Yeah.
never get myself moving fast enough to really take care of everything that I need to take care of in real life. So,
Yeah.
I
Real
always,
life comes first.
yeah. Well, I mean, I just need to get off my lazy ass a little bit faster. So, but I mean, I also like to enjoy, having some off time as well. So, you know,
Yeah.
so okay. We're gonna be continuing on with our Unreal study session. Now, let's see, where did we leave off yesterday? I think we were doing,
We did the problem with platform-specific audio
yeah,
APIs. We
that's
did
what I
that
was,
part.
that's what I was thinking as well. We left off at the audio mixer is the solution, right? So,
Yep.
um, no, I haven't gotten any feedback to my knowledge, right at this
I
moment in
haven't gotten
time
any.
for
Either.
like comments or anything along those lines. So, I mean, if anybody wants to add any comments, concerning our Unreal videos, I mean, they're more than welcome to do so as long as it's constructive. Like, hey, we have some questions about sound. Well, maybe help us out if if you know. Um, we'd be really appreciative of it. But obviously, that's if you want to, you know. So we're going to be continuing on with the study of all these topics for Unreal because we need to have at least a basic understanding of them. I don't really want to jump into, um, trying to figure out on the fly, trying to build, some kind of clone game and messing up big time during it. Not to say that we're going to be
Yeah.
absolutely perfect when we actually build it, but I still want to have at least some idea, some kind of concept about how to actually do, you know, what we need to do. So, um, so that's why we're kind of going through all these topics with the 4.27 documentation. So you guys can follow along if you want to. Um, then we're going to be doing a clone. What we're
Yep.
going to be doing, I don't really know, but we'll
We
figure
haven't
that.
decided that yet.
Yeah, exactly. We'll figure it out once we get there. Um, and then again, we're going to be considering, we're going to try to do a game, you know, ourselves that isn't a clone. Um, whether it's, the old game that I was trying to do on Unity but was failing miserably on, GGG, or if it's like something else, different. I don't really know. We'll get to that.
Mm,
So
yeah.
that's another topic for another day. So, um, but for the time being, we're just gonna keep on going through the instructions of this and learn as we go. And uh, maybe we'll learn a little bit more about audio. Although there's some topics here that's like, woo, uh,
Yeah.
a little beyond us right at this moment in time. But I mean, like I said, who knows? We might learn it all by the time we've made a couple games. You never know. So, okay, so the solution to all of and let's get into the topic here. The audio mixer is the solution. So, the solution to all of these issues is a single multi-platform audio rendering API, what we call the audio mixer. With the audio mixer, since there is one common code base for all platforms, feature parity feature parity is much more easily achieved. Development time is optimized as programmers are able to implement a new feature once and can expect it to work on all platforms. Testing, documentation, and sound designer implementation and mixing is also simplified. Apart from the subset of unavoidable and specific cases, things will sound the same and behave the same across platforms. I mean, that's yeah, at least that's the hope. And then they can't
Yeah.
always,
You might want
it's
to put that in quotations.
exactly, it's like, you might want it to sound the same and behave the same across all platforms, but let's face it, all the platforms everywhere are not built the same. you know, Xbox is built differently than the PlayStation, which is built differently than the Switch, which is built differently than the PC. It's like there's a lot of differences when you look at them. I mean, and let's not even get into Apple. Apple's in its entirely different world. you know, and hey, if they want to keep on doing that, that's their business, right? Um, you know, I just don't really want to use any of their products because typically it's very expensive to work with their hardware. So I mean, if you think you look at a common PC and it's like a couple thousand. You look at the equivalent on Apple and it's like maybe add 1,000 more. It's like you know it's like ouch. Um,
Yeah.
but I mean they do their own thing there. So, on one hand, sure, it's perfectly fine. You know, it's a free country, right? You can do whatever the hell you want. But on the other hand, you can't integrate Apple with other hardware very easily. You're going to have to do a lot of work to try to make sure that, everything kind of conforms with between the two because there isn't really any um, the standards of PC don't necessarily apply to Apple. So that's all.
Mm,
So, supporting new platforms is fast. It often takes just a few days and a couple of hundred lines of code. Writing an interface for audio engine plugins becomes not only very doable, but a primary avenue for innovation. In addition, fixing bugs and optimizing code benefit all platforms. True.
mm.
Um, let's see. I mean, hmm. I don't know if I would say, supporting new platforms is fast because, I mean, like I said,
Depends how much it changed.
yeah, well, I mean, um, like we discussed yesterday, where there are some platforms that don't even send out documentation concerning their their machine, and everybody's gonna have to, if they want to support said machine, they're gonna have to, you know, are they some kind of, they're gonna have to um, look into a crystal ball just to see, what what functions they need to use. You know, um, you need to have the right kind of documentation for that. So, I don't know if supporting new platforms would be considered fast,
No.
but I don't know. And, maybe it, I don't know what the process is, at, um, you know, uh, who is it that built, that made Unreal? Was it Valve? I think it's Valve, right?
No. Valve has the Source engine.
Right. Source. Silly me.
And
Da-da-da-da.
Epic is the Unreal.
Epic Games, right? Okay. Yeah, and they've, obviously they've done a really good job with the Unreal Engine over the years. Um,
Yep.
so, um, but, so I don't know exactly, what all they do, you know, when like a new platform comes out, how are they able to, what's the process that they use to look at the new platform and try to work with the Unreal Engine to, you know, allow for that, um, the merging into the new platform. I don't really know. Obviously, they have some legacy code that they can probably, go with, all the other previous platforms. So there's not really that much change along those lines. They're just basically going to be kind of looking at they're going to try to look at the API for the new platform and go, okay, how can we, take the code that we've already built and allow for it to integrate with the new platform. So maybe it is fast for them now, but probably wasn't that way when in the beginning. So, um, all right. So let's see. There will still remain platform-specific challenges. Each platform has different CPU and memory capabilities or different hardware support options. However, in cases CPU or memory deficiencies, the audio mixer can employ features that automatically reduce the CPU load via feature disablement, quality reductions, and so on, or memory load, memory pruning at cook, automatic downsampling, and down quality encoding. Sound designers and audio programmers can tune the audio mixer to hit a given performance and memory target for a given platform. So obviously there's some uh, keywords being used here that I'm not all that familiar with, like downsampling. Not quite sure exactly what that is referring to directly. Um,
Mm,
Memory pruning at Cook. Um, I might be able to, make an educational assessment as to what they're trying to mean here, but again, I wouldn't know like 100% if that's correct. Um, and down quality encoding, which I would imagine, hey, if the quality isn't working the way it should, then maybe it, automatically like reduces down the quality automatically, maybe. I don't know.
mm,
Um,
very likely.
yeah. But how would it know, like, hey, I'm not hitting the benchmarks, you know? or like, how would it know, like, hey, I'm not hitting all these benchmarks, I should lower myself or something like that. I don't really know. Eh, if that is indeed what it's going through, how would it know? Um, so, but obviously, if they do have these kind of features on there, then that could potentially mean some really good, useful tools for us, the programmers, for a new game. Putting that information in so that, hey, if if we do like a mobile game or something like that, it will check the limitations of that mobile phone and maybe automatically set the values for that phone so it doesn't necessarily explode it. It's like, oh, hey, I'm trying out this new game, and it's basically doing everything to my CPU. Oh my God, the CPU is super hot. Up, Not to say that that actually happens, but still. Um, you know, uh, at least I would hope that the phone doesn't necessarily explode in your hands. I mean, there have been,
Yeah, there was I believe a Galaxy model that its battery would blow up,
yeah,
literally.
yep. So, um, one would hope that the phone was shut off prior to any overheat to explode, but you never know. Um, but I'm just putting that out there. Let's say, um, so maybe it does do that. Again, I don't know. We'll have to see. So, why it's called the audio mixer. Another word for audio rendering is audio mixing. Okay. Since the word rendering is used most exclusively in Unreal Engine 4 to refer to graphics, which again, that's something that
Yeah,
I'm used to. So yeah, okay.
same.
We decided to call the new audio renderer the audio mixer. Okay. However, this decision has sometimes caused confusion within the audio community and others due to the ambiguity of the word mixing. Okay, makes sense. It can be confused with the operation of volume, loudness, mixing. Okay. Makes sense. You know, here I'm thinking the audio mixer is something that just basically handles all the processes of, like, loudness and so on and so forth. As a like a mixing board. You're changing the volumes and settings and so on and so forth. You're doing the reverb. That's what I was thinking that it was all about.
Yeah.
But they're also including the rendering into it as well. So okay. Um, the Unreal Engine 4 audio mixer is essentially doing the same thing that a hardware mixing console does. It adds together sound sources after processing them through a variety of parameters and effects processors, including through submixing and master effects processors. So, yeah, but it is essentially like a mixing board. Like, I don't know if you've seen any of those pictures or anything like those along those lines.
I have, yes.
Here, hold on,
And I
let me.
have seen a virtual mixing board back on my old jobs.
Yeah, let me see if I can find a volume mixing board. Let me see if I can get like a image for it or something like that. So there we go. So on my stream, I'm just kind of showing, you know, like the common mixing board that I'm familiar with. Well, not familiar, but I've seen enough around. I've been enough, I've been on the internet enough, where I've seen this, you know, commonly shown in like recording studios, for example.
Yeah.
Um, so you see a board like this and you're like going, oh, okay. So if this is what the Unreal Engine is trying to go for, which makes sense, right? You're trying to like lower like different channels, or you're trying to you know like maybe um there's like certain pitches or something like that that's causing problems, or whatever. You know they have this board to try to um uh make it pleasing to the ear. So
Yeah.
so I would imagine that that's essentially what the Unreal Engine audio mixer is kind of all about. But I mean,
Does
like,
sound in a way that way.
yeah. But at the same time, as they stated, their audio rendering is also added into that as well. So, it makes sense. Makes sense. So, all right, moving on.
Yep.
So, the audio mixer architecture, the platform layer. The audio mixer has a minimal platform-specific API layer. The platform API wraps all the necessary details of accessing audio hardware for our various platforms, and this layer deals with querying hardware capabilities and, where needed, hardware state changes, and sets up a multi-platform audio mixer to feed audio to the hardware. Okay. Some platforms require additional code to handle a variety of platform-specific nuances, like state interruptions, app suspension, device swapping, and so on. While in other cases, support was added to leverage platform-specific enhancements like hardware-accelerated decoding. In these cases, there can still be a good deal of platform-specific code required. Note that this platform-specific layer is also dealing with some of our remaining platform-specific features in Unreal Engine 4, like creating runtime decoders for our various codexes. Okay. Um, I think that was fairly um, descriptive enough for the most part.
Yeah.
I didn't really see too many problems with this particular paragraph, or these particular paragraphs that were like really kind of blew my mind for the most part. Um, Now, obviously, you know, state interruptions, app suspension, device swapping. We don't really know, or at least I could, again, I can make an educated guess as to what these might entail, but would that be would it be correct though? That's the problem. You know, they didn't actually state outright, what these.
No, there are no examples of what they
Yeah.
are.
So, I mean, I can make some assumptions like, hey, app suspension. Um maybe the person turned off the console like right then and there, right? With it, like, or maybe there was a power outage, and there goes the game. So you don't necessarily need it continuing to run or anything along those lines, right? You know, um, so, but then again, if you're dealing with a power outage, I guess it wouldn't necessarily run anyway. But maybe the user decided that they wanted to shut down the app like right then and there. Um, like say you're playing Warframe, for example. Like, me and Blackheart's gonna be playing Warframe later on tonight, right?
Right.
And we're playing the game. You're hearing the sound, you're hearing the combat and the music and so on and so forth. You're going through that, and like, I suddenly click the X accidentally on the application and it shuts down. Are you still hearing the music, the sounds, the combat and stuff like that, afterwards? More than likely not, right?
No, no.
You know,
I think
uh,
this was more of a common issue on older games.
true,
I
true.
do remember some older games when I would shut it down and I could still hear some of the sound effects or music still running.
Yeah, yeah. Well, I mean, let's face it, that or, for one thing, obviously, as technology continues to advance and stuff like that, it might be a little bit harder to integrate with older, more archaic code, um, because some of the older code might be deprecated, for example, right? So it might be saying, hey, I want to use these functions, that your, more advanced version no longer uses, right? You know, like, hey, I want to use this function. Well, you can't because it's no longer there. How does the game handle that, right? So, um, and back then they were still trying to figure everything out as well. So, um, hearing the audio when you shut it down and when it, shuts itself down was, well, obviously, fairly common because they didn't really, uh, they might not have had like an engine to do that kind of work before. It was all kind of done, with game code or something like that. So it just kept on sending, the CPU kept on like looking at the code for some reason and just kept on playing the audio over and over and over again or something like that. You never know. Um, that's one of those things where it's like, uh, older code can be a little problematic, um, but I mean, as we continue moving forward, then things, problems like that, hopefully get reduced over time. And but at the same time, as programmers, we shouldn't necessarily forget about those mistakes either. You know, um, take for example, the old Y2K debacle, right? Um, now, for those of you that don't really know, prior to 2000, the typically the programmers typically wanted to save on memory as much as they could because memory was limited back then. They only had so much space that they could use to do everything that they wanted to do. So they cut corners wherever they could to make sure that everything was working the way they wanted it to work. Well, one of the shortcuts that they did was they reduced the year um, from the 4 digits that it is now, obviously in coding standards. They had it down to a 2-digit number, so that it was just displaying um, the basically the decade of it. Okay, so it would show you know the 80s, the 90s, but once it hit 2000, the worry was that all the computers would set itself back to the 1900s, you know, before computers were even made. you know, um, hell, back then, cars were barely, being made at that point. Um, so, um, the I mean, they were still being made, but still, um, but it's one of those things where it's like, if the date rolled back to the 1900s, at that switchover, then everybody that was born by a certain date are no longer alive, kind of thing. It's like all these programs that are saying like, hey, we need to make sure that you're we want to make sure that you're indeed like 65 years old. Oh wait, you're not born yet. So, why would we send you out like, um social security checks or something like that? It's like, um um wait, what? you know. But the problem was that they were like going, okay, we need to solve this now, you know, because they were worried that if it switched over, it could cause a lot of problems, you know. So, but the problem was that all the programmers that did all that work initially, they were either like gone, like they'd already passed away, or they were out of the industry for the most part, you know. Um, so, either they had to get their newer programmers to try to do the work to try to fix that problem, switch the 2 date to a 4 date, um, or they had to um, go back to the um, to the old programmers to try to figure out what they did and change the code so that it was no longer a 2 digit but a 4 digit. So it was chaotic. It was chaotic during that time. So um, a lot of people were kind of scared about you know the world is gonna end. Because um, they were afraid that hey, if this code doesn't if the code doesn't get changed at all, then everybody's like, you wouldn't necessarily have like applications anymore, or you would have problems with a person's social security and age, and um, any kind of records would be messed up because now like an old housing contract, for example, would be pretty much null and void, for example, right? So I mean, there was a lot of potential disasters, that could have happened at that moment. Not to say that there was I'm there was still paper evidence and stuff like that, right? But still, there's a lot of um, there there was a lot of fear along those
Yeah,
lines. So sorry for going on a tangent.
no problem.
All right. Let's move on to the next topic here. And oh boy, it's a pretty long one.
Yep.
Buffer generation. Different platforms have different methods of feeding audio to its hardware. Some platform APIs are designed to push audio to the hardware into a queue. The client app is responsible for keeping audio queued up. Other APIs are callback based and will call into client code when the hardware needs more audio. In both cases, the audio mixer employs a multi-buffer scheme that generates future audio buffers while hardware is rendering the current buffer, such as the buffer you are listening to. Okay. Um, Now, what I'm what I'm a little worried about, obviously, for this, they're talking about how, one audio is being pushed onto the hardware into a queue, right?
Right.
Well, typically, you know, when you're reading that, you're like, okay, well that's all well and good. You're showing like you're talking about one sound for the speaker, right? But let's face it, there's some you know, when you're talking audio, you could be having some things that are happening at the same exact time, such as, music, sound effects, um, speech, whatever, right? So it's like, okay, you know, um, how does the hardware go about tackling like multiple sounds that need to be played at the same time, right?
Hmm.
Um, sure, it's great to have like a multi-buffer scheme that you can put like multiple audios into and stuff like that. That's great. That's all well and good, but how do they handle trying to play multiple buffers at the same time? You know, um, it's great, that they have that, right? Especially when you have like multiple sounds that are trying to come, that are trying to be played at the same time. But how does the hardware handle that? But
Hmm.
let's move on. Maybe they'll explain.
Hopefully they explain it.
Yeah. If the audio mixer takes too long to render the next buffer of audio, the buffer queue starves for push APIs. Or if there is no audio available when the API calls back for callback APIs, there will be an audible gap in the playback. This is called an underrun, sometimes called starvation, and should be avoided at all costs as it always sounds very bad. I mean, sure, you know, um, I guess you might say, if you're like listening to me, for example, and I'm like, you keep on hearing me go, and and it with those kind of gaps, and you're like going, what's going on there, right? So,
Right.
um, now you know, it could be that starvation might be along the lines of like maybe the information isn't there, so it has those gaps in there, or um maybe it's not playing back that sound, or it wants to play that sound, but unfortunately it kind of puts that gap in there. So you're like, um, so you're saying, um, STA, and then a couple seconds later RT for start, right? So it's like st art, you know. Then it's like, that kind of starvation maybe, you know. Um, so um, hard, not quite sure. It might apply for both. I don't know. I don't really know, but um, an underrun will cause sudden discontinuity in the audio stream and is perceived as a noise burst, either as a pop or for a short underrun, or stutter for short and persistent underruns, or a major dropout if audio for long running audio underruns. The sudden amplitude change can even cause damage to audio receivers or speakers. Ooh, okay. In most cases, underruns are due to CPU saturation. The audio mixer is doing too much work in the time it has. In other cases, it might indicate a blockage in the Unreal Engine 4 task graph for async decoding or synthesis, and some other problem. It's also sometimes difficult to distinguish a click or pop in the audio from an underrun or vice versa. Okay, interesting. Okay, so what's interesting here is that they're kind of giving a little bit of a description about, what you might hear in an underrun. So now you might know how to maybe deal with it afterwards. Like if you hear, like a pop, you know, for the audio, then you know that it's a short underrun and therefore, you might go, okay, how do I solve this short underrun? You know. So, um, stutter for persistent underruns. So it's one of those things where it's like, okay, this is useful information in that, we can, um, if we're actually hearing it, in our audio, then we might be able to kind of troubleshoot how to go about fixing it, you know. So so I like that. So um and of course, if we need to, if there's parts where it's like, hey, if you're dealing with this kind of issue like later on, then they'll provide us, ways of trying to fix it. Or maybe even the engine itself determines it too. Maybe it'll go, hey, um, I'm getting a pop from the audio, which is caused by a short underrun. These are some solutions that you could do to fix it, or something like that. I don't know. I'm just thinking out loud. So, but audio mixer is doing too much work for the time it has. Um, so it might mean that we might need to, like, um, if the CPU is being um, overloaded with audio, then we might need to lower the amount of audio going to it. You know, um, like before there was the concurrency. You know,
I think it was, yeah.
um, so if there's like too much audio going into the CPU, we can then use concurrency a little bit more and limit how much audio is going in there, for example, right?
Yeah.
So so obviously there's ways to try to combat, you know, combat an underrun or whatnot, but yeah. So on the other end of things, it's possible to generate too much audio up front. In these cases, game events will lag further and further from real time. And this is perceived as latency. In extreme cases, this is called an overrun, and is also something to avoid. Makes sense. Real-time audio engines need to find the balance between underrunning and overrunning. Underrunning is avoided at all costs, while overrunning, which is required to some degree to prevent underrunning, needs to be below the threshold of perception. Okay. I mean, makes sense. Um, I wonder what would be like a good example of an overrun.
Hmm.
Mm,
I think I have very few cases, but I don't remember the game. I think it was a shooter where I had this sort of situation where someone was like kind of lagging. I can't remember now right now what game it was.
Oh, I think I get um I think I can think of something. I mean, um, there's an old movie that there's one scene that I absolutely love where it's called Singing in the Rain, the movie.
Sounds familiar.
And the scene in question is that they're uh, finally getting you know voice actors to actually say their lines for the very first time in the movie theater. Before it was just silent movies. You just have, you know, the actors acting out, or trying to, you know, emote the scenes kind of thing, and the dialogue would just show up on screen, and then you'd have like maybe a piano front, just playing the song, right? For the
Right.
movie. Um, So that's typically how it was, before, right? But now they were like on, oh, hey, you know, we can actually add audio to movies, at the same time, hey, we can add this in, right?
Mm.
So this the movies this one movie studios, that is, focused on our main actors. They try to do that. They get the hardware and stuff like that. They try working with it, and they put out their very first movie. It's a talking movie. Yay! Right?
Mm.
Um, and there was one part where the audio went out of sync with the movie itself. So you you had this dialogue between, I guess, the damsel in distress and the main villain, and um, and the villain was like going, "No one can save you. You're mine forever," and the lady's going, "No, no, no," and the guy's like, "Yes, yes, yes." But the audio gets out of sync, so now you have the lady, you know, shaking her head no, but actually saying yes, 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 and the guy's going no, 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 shaking his head up and down. So it just hilarious scene. Um, just seeing that, and you could just um, and obviously this serious movie that they were wanting to make, that was filled with drama and stuff like that, turned into a comedy. Everybody was just laughing hilariously about the sound gaffes that were being made on there, right?
Right.
Um, hilarious movie. I enjoy watching it. I would recommend that very old movie to anybody that has not seen it. But I can imagine that kind of sound, like um, problem could be could maybe can be considered, a problem with like latency or overrun, meaning that you had a little bit of a problem, like the CPU didn't it was getting too much or something like that, so it just kind of said, okay, I'm dealing with too much here. We're gonna have to, uh, I gotta take care of this. Um, I gotta take care of the mathematicals and graphics and stuff like that. I'll deal with the audio a little bit later, and suddenly you have that effect happening. Where now, like you try to like shoot a gun, and then like 10 minutes later you actually hear the sound effect or something like that, right? It's
Mm.
like, okay, there's a bit of a problem. So, um, so that's what I'm thinking is kind of going over there. Or
Yeah, it definitely sounds that way.
yeah. So, I think we're probably gonna do this last paragraph here, and then we're probably gonna go ahead and close it down because next one is probably gonna take a little bit longer than 3 minutes.
Yeah.
So, but
Yeah,
finding
we
the
still have plenty to go over.
yeah, finding the right balance can be tricky and is often platform dependent. Indeed. To that end, the audio mixer is architected to allow sound designers or audio programmers to choose per platform the size of the audio buffers to render per audio buffer render. Wait, what? The size of the audio buffers to render per audio buffer render.
Uh,
Uh, um, okay, sure. And how many buffers to render ahead of the currently audible buffer? Okay. This sentence sounds
y-
perfectly fine. How many buffers to render ahead of the current audio buffer? Understandable on that. Makes sense. But the other one, the previous one, it's like, wait, what?
well, yeah, I was like, wait, what? What?
Um,
I,
sorry.
the second render shouldn't be there.
The size of the audio buffers to render per audio buffer render.
Yeah, that last
So,
render, I feel like it shouldn't be there.
well, and okay, so, um, it I can't say that it's completely wrong though, but it's really weird to read. Um,
Yeah,
because obviously you have the audio buffers that are generated, and obviously you're rendering them to be able to be played, right? So, and obviously depending on the platform, you may have multiple different audio buffers. And you have to render each and every single last one of them, right?
right.
So per audio buffer render, that makes sense, right?
Yeah.
Okay, so but now we look at the first half. The size of the audio buffers, meaning like, hey, we create these audio buffers to put the audio into to be played. So you need to know how large those audio buffers need to be. Um, and then you need to go through the process of rendering them. Putting them both together, on the other hand, is like, okay.
Yeah, it just sounds weird.
Yeah, it definitely sounds weird, but at the same time, it still kind of makes sense a little, kind of.
Kinda.
So, um, okay, but I think that's probably where we're gonna have to call it, my friend. Um,
Yeah.
but I mean, like you said, there's still plenty of topics that, plenty of paragraphs, plenty of things that we're going to need to kind of go through anyway. So,
Yeah, there's
well,
still 16 more topics left.
yeah. So, we'll
Yeah,
continue.
might as well leave it for tomorrow.
Yeah, we'll continue on with the audio mixer threading model tomorrow. So, um, any questions or anything that you'd like to maybe add in before we kind of
I can't
end
think of
this?
anything.
Okay,
I can't think of anything right now.
okay. I'm assuming that you're pretty much good with what we've all covered for the most
Pretty
part.
much, yeah.
Um, so I do like that they've it doesn't feel like they're still kind of adding in like keywords here and there, like starvation, for example. But here's the thing, they're actually kind of describing it,
Yeah.
in a way that, is understandable to me. So, I kind of like this overall description that they're doing here, because at least I get to kind of understand what they're talking about, so we can use that, later on. Not to say that we're going to be perfect at it, but we can still use it. So,
Yeah.
I kind of like. I'm really liking this overview so far. So I think this entire overview has been pretty much, um,
Well explained.
yeah, or at least I'm getting that kind of impression from it.
Yeah.
What about yourself? How you feel about it?
Yeah. I do appreciate that they take the time to explain a few things.
Yeah. So so that's good. That's good.
Yeah.
Um, you know, it really sucks when you don't get a like a really good description of anything, or they're like, hey, here's this information. If you don't know what we're talking about, then well, oh well, it's like, ah. you know, it's just one of those things where it's like, come on, guys, help us out here. We're trying to learn. We're trying to learn Unreal Engine as well. Help us out with this because, um, you know, otherwise we're going to be, um, unsure of what we're going to be doing when we actually get to, working with the engine itself, right? So,
Right.
um, but obviously, they're not necessarily going to be hearing this, and it's like, we can complain all we want, but they're not necessarily going to be hearing us.
Yeah.
So, so it's just kind of unfortunate that, we're in a sense um, dealing with a tutorial that, you know, might have topics that we're not very familiar with, and they don't really go into full detail on, or basically say, hey, you need to be a sound engineer to understand this. It's like, okay, but what if we're not? You know, it's like, oh well, good luck. It's like, ah,
Yeah.
what are you doing? Stop that. Um, okay, but I think that's where we're gonna go ahead and close on down for tonight on this.
Yep.
So, um, let's see. Yeah, we'll pick this back up again tomorrow. So thank you very much for watching there, everybody. I think we'll go ahead and close on down on this. So I appreciate everybody being here for this particular topic. Um, like I said, if there's anything that, well, like, you and I we we got a little bit enough about the information that we kind of went over. But
Yeah.
maybe, um,
Maybe if we understood something wrong, then maybe correct us down in the comments below and what it
indeed,
actually might have been and what we got wrong.
indeed. That's kind of what I was going for. Nicely done there, Blackheart. Thank you for saying exactly what I was thinking. um, also, help us out with the YouTube algorithm, with the like, comment, subscribe, and all that kind of jazz. That would be fantastic for us. That would help us out. Check out our descriptions, both Blackheart and mine's descriptions in these videos that we upload onto YouTube. Um, Check out the links contained in there. Check out each of our channels. Help us out that way. So if you're watching this on Blackheart, go check out my channel, or if you're checking out my channel, go check out Blackheart, vice versa. So, um, and we look forward to any kind of comments that you all leave. So hopefully, don't be afraid to, leave any comments. We really would appreciate those. So,
Yeah.
but that's where we're gonna go ahead and end this video, or at least on my end. I'll let you kind of do your own ending, my friend. But
Yeah, the minute will do it.
yeah, I'll go ahead and end the stage here, my friend. So you take care of yourself, and I'll see you in about an hour for Warframe.
Yep.
You go and get yourself some food,
Yeah.
and I'll see you in a little bit. Okay?
Sure. See you in a little bit.
All right, man. Take care.
Bye.
Bye. All right. So that's it. That's where we're gonna go ahead and end it for today. So um, again, thank you all very much for joining us for this portion of the stream. If you're watching it via stream, or if you're watching it via the video, if you're watching via video, then please feel free to check out the other videos that we've covered so far. Whether it's for the Unreal, maybe you want to go through some of the game playlists that we've made on either of our channels, of course. Um, give us some support if you're so inclined. We would really appreciate it. But that's it. That's where we're gonna go and end it for tonight. So thank you very much for watching. I appreciate it. Hopefully I catch you next time. But until then, take care. Have a good night. Stay healthy. Stay safe. And I'll catch you strangers next time.